I mean, last year alone, OpenAI spent over $700 million just on compute power for training their models. That's more than some small countries' entire GDP.
$700 million just on compute? Wow, that's an insane amount of resources. So why are we spending so much on these models, and why are we talking about it now? It feels like the conversation is shifting.
Exactly. We're on the cusp of a major shift in AI, from chatbots that react to prompts to autonomous systems that proactively solve problems. Think of it like this. Right now, we have really smart parrots. They can mimic human conversation, but they don't really understand what they're saying.
And the shift you're talking about is moving beyond the parrots?
Precisely. We're moving towards agentic AI, systems that can perceive, plan, and act in the world with minimal human intervention. Imagine a world where your AI assistant not only answers your questions, but anticipates your needs and takes action on your behalf. But if we don't get this right, we're talking about systems making potentially impactful decisions with minimal oversight. And that's a scary thought.
Okay, so agentic AI. Let's break that down. What exactly is it? How is it different from the AI we're used to, the chatbots and recommendation engines and the like?
The key difference is autonomy. Traditional AI, like the recommendation engine that suggests your next Netflix binge, is reactive. You watch something, it suggests something similar. Agentic AI is proactive. It sets goals, plans how to achieve them, and then executes those plans, adapting as needed. Think of it like a self-driving car versus cruise control. Cruise control keeps you at a set speed, but a self-driving car navigates traffic, makes turns, and chooses the best route to your destination.
Okay, that helps. So self-driving car equals agentic AI. Reactive recommendation engine equals traditional AI. But what are the components that make this autonomy possible? What's under the hood of an agentic AI system?
Great question. There are three core components: planning, memory, and tools. Planning is the ability to break down a complex goal into smaller, manageable steps. Memory allows the agent to learn from its past experiences and adjust its strategies. And tools provide the agent with the means to interact with the world, whether it's accessing APIs, searching the web, or even controlling physical devices.
Let's dig into each of those. Planning. So how does an AI plan? What does that actually look like in code?
It often involves using a large language model to generate a sequence of actions. The LLM is given a goal, and it uses its knowledge of the world to figure out the steps needed to achieve that goal. For example, if the goal is book a flight to London, the LLM might plan steps like search for flights, compare prices, select a flight, and book the flight. The crazy part is, the LLM is essentially writing its own to-do list.
Okay, I can see that. But that sounds incredibly brittle. What happens when something goes wrong? What if the flight booking API is down or the user's credit card is declined?
That's where memory and tools come in. Memory allows the agent to remember past failures and successes and to adjust its plans. If the flight booking API is down, the agent might remember that this API is often unreliable and try a different one. Or it could use its tools to search the web for alternative APIs. The agent is constantly learning and adapting, just like a human would.
So the memory isn't just about remembering past actions, it's about remembering the outcomes of those actions. It's learning from its mistakes.
Exactly. It's reinforcement learning, but on a much grander scale. It's not just about learning to play a game, it's about learning to navigate the complexities of the real world. And the tools are the agent's interface to that world. They allow it to take actions and observe the results. Think of it like the agent is the brain and the tools are its hands and eyes.
And what are some examples of these tools in practice? Are we talking about physical robots or are these more abstract?
It can be both. In some cases, the tools might be physical robots that can manipulate objects in the real world. but more often they're software tools like APIs, databases, and web browsers. For example, an agentic AI system designed to manage your calendar might use APIs to access your Google Calendar, send email reminders, and schedule meetings. Or an agent designed to automate your customer support might use a web browser to search for answers to customer questions and then use an API to respond to those questions.
Okay, that makes sense. So planning, memory, and tools. Got it. Now, where are we seeing this in action? Are there real-world examples of agentic AI that are already making a difference?
Absolutely. One great example is in supply chain management. Companies like Amazon are using agentic AI to optimize their logistics, predict demand, and manage inventory. These systems can analyze vast amounts of data to identify potential disruptions in the supply chain and then take proactive steps to mitigate those risks. Think of it like having a superpowered logistics manager who can anticipate problems before they even arise.
So instead of just reacting to a shortage, the system predicts the shortage and reroutes shipments proactively.
Exactly. And it's not just about predicting shortages, it's about optimizing the entire supply chain, from sourcing raw materials to delivering products to customers. These systems can make decisions about where to locate warehouses, how to route shipments, and even how to price products. It's a level of automation and optimization that was simply impossible just a few years ago. Another example is in cybersecurity. Agentic AI systems can be used to detect and respond to cyber threats in real time. These systems can analyze network traffic, identify suspicious activity, and then take automated actions to block attacks and protect sensitive data.
So, like a self-healing network.
Precisely. It's like having a virtual security guard who never sleeps and is always on the lookout for threats. And the crazy part is, these systems are constantly learning and adapting, so they can stay ahead of even the most sophisticated attackers. Think of it like an immune system for your network.
Okay, those are compelling examples, but it feels like there's a potential for bias to creep in, especially with the planning component. How do we ensure these agentic AI systems are making fair and ethical decisions?
That's a critical question, and it's something that the entire AI community is grappling with. Because the planning is essentially hallucinated by the LLM, that hallucination can reflect existing biases in the data it was trained on. Imagine an agentic AI system used for loan applications. If the system is trained on data that reflects historical biases against certain demographics, it might perpetuate those biases in its loan decisions. This is a huge area of research and development.
So, what are the solutions? Is it just about cleaning the data, or is there more to it?
Cleaning the data is a start, but it's not enough. We also need to develop new techniques for auditing and explaining the decisions made by agentic AI systems. We need to be able to understand why a system made a particular decision so we can identify and correct any biases that might be present. And we need to build in safeguards to prevent these systems from making decisions that are harmful or unethical. Here's where it gets interesting. Most engineers think about agentic AI as just more AI, a linear progression from chatbots. But it's not. It's a fundamentally different paradigm. It requires a completely different way of thinking about system design. It's not just about building a smarter model, it's about building an autonomous agent that can reason, plan, and act in the world. This shift requires a new set of tools, techniques, and mental models. It's a whole new ballgame.
So it's not just about plugging a bigger LLM into your existing architecture, it's about rethinking the entire architecture from the ground up.
Exactly. Think of it like moving from a traditional assembly line to a fully automated factory. You can't just add a few robots to the assembly line and expect it to work. You need to redesign the entire factory to take advantage of the robot's capabilities. Similarly, you can't just plug an agentic AI system into your existing software architecture and expect it to work. You need to rethink the architecture to support the agent's autonomy.
And what are some of the key architectural considerations? What are the things that engineers need to be thinking about when designing agentic AI systems?
One key consideration is modularity. Agentic AI systems need to be highly modular so that they can be easily adapted and extended. Think of it like building with Lego bricks. Each component should be self-contained and reusable, so you can easily assemble them into different configurations. Another key consideration is observability. You need to be able to monitor the agent's behavior and understand why it's making the decisions it's making. This requires building in logging, tracing, and debugging capabilities. And finally, you need to think about security. Agentic AI systems can be vulnerable to attacks, so you need to build in safeguards to protect them from malicious actors.
Okay, so modularity, observability, and security. Those are all critical. But let's get practical. What should a software engineer do differently after listening to this? What are three specific, actionable things they can do to start preparing for the age of agentic AI?
First, start experimenting with LLMs and tool use. Don't just use them for chatbots, try to build small, autonomous agents that can perform simple tasks. Think of it like learning to ride a bike with training wheels. Second, start studying the architectures of existing agentic AI systems. There are many open source projects and research papers that describe how these systems are built. Think of it like reverse engineering a complex machine to understand how it works. And third, start thinking about the ethical implications of agentic AI. Consider the potential biases and